Hi, my name is Taylor Pemberton, and this is my project on the optimization of a non-hydraulic ambulance stretcher. Each year, EMS services transport 16 million patients to hospital ERs. The stretcher plays a huge role in this process and allows EMS personnel to transfer patients from unsafe locations and uneven terrain. Although stretchers and EMS are used to rescue patients and get them to safety, accidents can occur during the operation and use of the stretcher itself. Studies show that over half of the adverse events involving a stretcher were caused by the sudden collapse of the stretcher. This is defined as the stretcher mechanisms failing when the stretcher is in the upright position and the carriage falls to the ground. This is most likely caused by the stretcher being too heavy with the patient on board for the locking mechanisms on the stretcher to stay in place. Additionally, EMS staff have been known to experience knee and back pain from lifting stretchers up and down because they are so heavy. To avoid these issues, hydraulic stretchers were produced to reduce the burden on EMS staff. However, these stretchers are often very expensive and heavy. Because of this, many fire departments choose not to purchase hydraulic stretchers. For these reasons, I will be optimizing a non-hydraulic stretcher for this project. Additionally, I will be optimizing a stretcher based on Stryker specifications, as they are one of the leading manufacturers of stretchers in the United States. For this project, I will try to minimize the weight of a non-hydraulic stretcher, and in particular, the carriage of the stretcher. The carriage is everything excluding the bed and the wheels. These are the Stryker specifications I followed when designing my stretcher to optimize. Most importantly, the stretcher must be able to hold a maximum of 700 pounds. In order to find the optimum design for the stretcher, I created a simple SOLIDWORKS model of a stretcher that fits the constraints laid out in the previous slide. Then I imported this model into the software Inspire. This is shown on the right. The maroon color indicates the design space, and the gray is the non-design space where loads and supports will be added. This is important because Inspire will not run an optimization where there is a load or a support added in the design space. In addition, Inspire allows you to assign material to your design. In this case, everything in maroon, so the carriage of the stretcher was aluminum. The bed and the wheels of the stretcher were assigned to plastic. The total weight of the stretcher made of these materials is 652 pounds. Here we can see the load applied to the bed of the stretcher, which is 700 pounds, and the 4 supports placed on the wheels. Those are shown as the 4 red cylinders. In Inspire, it is possible to define the joints of the system for a more accurate optimization. Since I am concerned about the ability of the stretcher and the locking mechanisms being able to hold 700 pounds, I define the joints as locked, as this is how they would be when the stretcher is in the upright position. After running the optimization in Inspire, I was able to get an optimized stretcher. The photo on the right shows a stretcher after the optimized geometry has been smoothed and simplified. The total weight of the stretcher now is 457 pounds for a total decrease in 195 pounds. Thank you for listening to my presentation.